So in part 3, we tackled 2 more examples. We're looking at example 5. Example 5 says an open box with a square base is required to have a volume of 10 cubic feet because we know how much has to go into it. We want to express the amount of material used to make such a box as a function of the length x of a side of a square base. And the reason you would be doing this is it costs so much to build the box. You want to make sure that you're minimizing the cost of building, which would be minimizing the surface area of that box. So there's definitely a reason why we need to be able to do this. Okay, so let's draw a square box. So the key here is it has a square base. So this is x by x, and they tell us to go ahead and call the length of this length x of the side of the square base. So this is x by x. We do need the height to be something, so I'm just going to use h as height. Now what we're after is the surface area, the amount of material needed. So we need surface area. Which we're going to call just A. So the surface area would be the area of the base that it's resting on. That's how much material we need to make the bottom of the box, plus the 4 sides of the box. So again, just writing it in words so we can pick up what we need. So the area of the base, well, the base is what it's resting on. That's this bottom piece, which is x by x. So that area would just be x squared. What about the 4 sides? If you take a look at this side that's facing us, this side right here, it's dimension x by h. But wait, so is this one x by h and this side and the back side? So all 4 sides have the exact same dimensions of x times h. Well, that was not too bad at all. Again, we have the same issue. We need to get rid of the h. Not all that we need from this, but it's not a function in terms of x because we need to eliminate the h. So we're going to leave that alone for a minute. I'm going to come back over here. The only piece of information we haven't used yet is the fact of how much volume this box needs to hold. So we know that the volume of a rectangular solid is the length times the width times the height. We know for our picture that volume is 10. So now we just need to pick up the variables that we've got. Our length is x. Our width is also x. And our height we used in h. So 10 is equal to x squared h. So again, we're going to solve for the formula or the letter we need to get rid of. We need to get rid of the h over here. So we're going to solve this equation for h. We can see that h is equal to 10 over x squared. And now we're going to substitute it. So that'll give us x squared plus 4x. Taking out the h, we'll put in 10 over x squared. And there it is. We'll clean that up a little bit. That's x squared. From over here, we get 40x over x squared. Remember, when you multiply, you just multiply numerators, then you multiply denominators. Go ahead and cancel the x out. So we'll end up with x squared plus 40 over x. And there's our area function in terms of x. So you now tell me how big of a base it is. I can tell you how much area or material we're going to need to build that box. Ideally, you want to minimize that when you're taking your calculus class. So example 6, our last example. Talks about taking a piece of wire and bending it into a shape. So example 6. A wire of length x, so I have a piece of wire, it is x long, is bent into the shape of the square. So I'm going to take that and then I'm going to bend it into a square. So literally bending it into a square. Express the perimeter of the square as a function of x. Well, hopefully this one makes perfect sense to you. So in other words, if I take that entire piece of wire and bend it into this shape, haven't I basically used up the x? So the perimeter is just x. That was pretty straightforward. Part B is the harder part. Part B says, okay, what I need to do now is express the area of the square as a function of x. So the area of the square is a function of x. Well, the formula for the area of the square is the side length squared. So we're going to have to backtrack and figure out what a side length is. Well, we had x. We're taking it and we're making 4 sides out of it. So each one of those sides is 1/4 x. So this side is 1/4 of x. This side is 1/4 of x, etc. This side. So that means that the area function is going to be 1/4 of x squared. So 1/4 squared is 1 over 16 x squared, and there's the area function. Now you're going to do one of the homework problems, which does the same thing, but instead of making it into a square, you're making it into a circle. So you'll have to work with the formulas for the area and circumference of the circle. So just as a reminder that for a circle, the circumference of the circle is 2 pi r, And the area of the circle is pi r squared. So in case you didn't remember those two, you'll need those on one of the ones. That wraps up section 3.6 and also chapter 3.